good morning, or good afternoon, or good evening, wherever you may be, and welcome to the latest edition of the Netscaler live demo. In the live demos, which are hosted twice a month, we at Netscaler like to give a quick demonstration of a feature or capability that you will find interesting and useful. We do like to hide what we're doing right there in the name, don't we? I'm Rich Faulkner, and I'm hosting the live demo today. I get the joy of introducing you to the really smart people who will be giving the demos. For our agenda today, we're going to be speaking about how to make your Kubernetes or cloud-native applications resilient with Netscaler GSLB deployment. I spoke about our really smart people earlier. Today, we have two of them that are going to be helping us out. And first is Mohan Patel, who's going to be telling us about how you can use global server load balancing to provide access to your Kubernetes applications. And then Diraj Gidam will be showing exactly how this is done in a real environment. But you didn't come here to listen to me drone on. So let's get things going. Mayur, take it away.
Thank you, Richard, for the warm welcome. Hello, everyone. My name is Mayur Patil. I'm from Netscaler product management team. Today, along with Dheeraj, we are going to talk about how our Netscaler GSLB solution going to help the Kubernetes application be available and resilient, which are deployed across multiple Kubernetes clusters. So with that, we have a very short and crisp agenda for today. I will be talking about what this feature is all about, how this GSLB controller is going to help you to configure the GSLB appliance, and then we will have demonstration of this particular use case. With that, let's get started. So what is a GSLB controller? Some of you would have already heard of the GSLB. Even if you have not heard, let me try to give you some little bit of introduction on the GSLB. So when applications are deployed across multiple data centers, the main reason for having such deployment is the high availability. And then second perspective for application availability is when they are migrating to the microservices. This is a new thing which is happening in the market, migration of applications from monolith to microservices. And in this context, when apps are getting modernized, availability remains there. The requirements of availability remains there. So the GSLB need is not going away, even if apps are getting modernized. That's the reason we have this GSLB controller in Netscaler, which will help you to load balance application workload evenly into the different data centers and across the different Kubernetes clusters. So what are the advantages you can achieve? So these advantages pretty much remain same what you could get for your monolith or traditional GSLB deployment, right? Such as for business continuity and disaster recovery, you want to have this GSLB setup. And that is also achievable for your microservices application too. And also, the GSLB helps you to avoid single point of failure. Because let's say if you're for any reason, your one of the data center is down, another data center can take the full control of the application traffic. That's how you have a full availability of application across the all user base. Then to provide the information on the different GSLB deployments, typically we have seen customers are deploying the GSLB across different choices. One very common is active-active. For business continuity and disaster recovery, customers are preferring active-passive. If you have a very significant workload distributed across multiple data center, in each data center there are multiple sites, then parent-child topology is also there. So all these details are available in the reference link, which is here. To just give you more high-level overview of GSLB controller, I would say that GSLB controller deployed in Kubernetes cluster will automate the Netscaler GSLB configuration. So this is one single line I would want you to have a key takeaway from this slide, that GSLB controller is for automating your GSLB appliance for your microservice application. Now, as we have set the context for why do we have a GSLB controller and why do we need a GSLB, let's dive deep into the use case of GSLB controller. Let me start from the topology point of view on the right-hand side. As you see, there are two Kubernetes clusters. One Kubernetes cluster is deployed inside A, and another Kubernetes cluster is deployed inside B. There are a couple of applications. This application can be same, this application can be different. You can see there is a Netscaler GSLB controller deployed inside the Kubernetes cluster, which will configure the VPX. In this topology, you will see that this VPX is the same appliance which will do the GSLB, and then it will do the ingress proxy job as well. Because that's the beauty of Netscaler. The single appliance can do both the operations one by one. First, it will be the GSLB. So client will come to the VPX with a DNS query, and then we will provide the information of the VIP, which is healthy, active from site A or site B, and then it will redirect to the right VPX as ingress proxy, and then we will take it to the end application. So this is the topology, and on the left hand side, I have just given the our customer profile. We have one customer where they wanted to deploy their mission critical apps into the Kubernetes workload, and they wanted to have a high connectivity for their IoT devices, and they wanted observability. So they had around 800 of HA proxies deployed inside the Kubernetes cluster. But due to some failure in identifying what is the problem of application availability, HA proxy was not able to confirm that where is the problem. So we provided our value proposition, GSLB, POC we did, and then we could provide exactly where is the problem, how efficiently we can do the transition when it is a failure in the one side to another. So that helped in this customer. And as you can see in the proposals, right, we have provided a GSLB, and as I was mentioning from the topology, the VPX, the appliance which is doing the GSLB and ingress proxy, the same job, it helps to lower the TCO. So now, having this topology into the mind, let's go and see how we can control and configure the GSLB from the live demo. Dheeraj, over to you. Let's show the magic here. Thank you.
Thanks, Mayur. So here, I have two sites, orange site and then blue site. And both the sites, there is a VPX Netscaler appliance running, which will be acting as a GSLB device along with the regular application delivery controller. So here the VPX is serving in the dual mode, first as a GSLB appliance and then as the app delivery controller. In case of GSLB appliance, it will be acting as an authoritative DNS device, ADNS, what we'll be calling it. And I have deployed an application in this cluster. Let me just show you how this application looks like. Yeah, I have deployed one application, CNN website, in the default namespace. And there are pods running for the same here. I will be sending the traffic for this application. And this application I have exposed using the Kubernetes ingress resource. I hope you guys are aware about the Kubernetes ingress resource. So you can see this particular application can be accessed on the host www.cnnappnetscaler.com. And for this orange cluster, the virtual IP address 175.145 will be used. Similarly, this application is also deployed in the blue site. And here you can see for the same host, the VIP is 175.146 in this blue site. Now let me just send traffic to this www.appcnn.com. So this is how our application looks like. It's a website talking about our cloud native portfolio, and we'll be like just showcasing this one. So this GSLB controller, going forward, I'll be like sending the traffic using the curl command, because the GSLB is like very much associated with the DNS, and for DNS, we would be like showcasing how the IP addresses are actually getting resolved to one of these sites. So subsequently, I'll be using the curl command to showcase the functionality. With that saying, let me just give that, okay, the traffic I will be sending from the curl will be something like this. Nice, sorry, something like this from here. So for the same host name, we'll be just checking whether the application is running, HTTP OK is coming, and what is the IP address it would be actually resolving to. Here in both these sites, I have deployed Netscaler ingress controller or CIC, which is doing the job of configuring the Netscaler ingress device application delivery controller and expose the application using these virtual IP addresses. The same is actually deployed in the blue site also. You can see this is actually running here. Now, let me deploy the GSLB controller. So as we have seen in the topology diagram, we had one NSIC, Netscaler Ingress Controller, another as the NSJC, which is the Netscaler GSLB controller. So I'll be using the hem command to deploy the same. And if you are aware about the hem, we can specify the deployment information in the values.ml. So this is the values.ml of the orange side. Here I'm specifying the Netscaler VPX address, that what ADNS IP should be used for the this GSLB deployment. So I'm actually specifying that, okay, for this orange region, local region is the orange, and there are two sites. One is the orange cluster, another is the blue cluster. Orange has this site IP 175.177, which would be used, and the blue one would be 175.178. The same kind of a file is present here in the blue side also. Here, the site information, it would be identical, and we would be now deploying the GSLB controller on both the sides. So before deploying a GSLB controller, we need to have the secrets. So secrets usually hold the credentials of the any device. In this case, we will be creating secrets which holds the credentials of our Netscaler appliance. So I have created Kubernetes secret for both VPXs, orange and blue. So this is the hem command what I would be like using to deploy the GSLB controller. Similarly, so it is deployed on the orange side. Let me also deploy it on the blue side. We should be seeing that, okay, this particular GSLB controller is now running here. You can see this orange cluster. This is actually showing the status as running. Similarly, it would be showing running in the blue side also. You can see this blue cluster ingress control is also running now. Okay, so our GSLB control is deployed. It is time to expose this application to the GSLB layer. And to achieve the same, we have a custom resource definition or CRD, which is called as the global traffic policy. So this is the GTP CRD, global traffic policy CRD. You can see I'm specifying the same host name which is used to expose the application, cnn@netscaler.com, and the destinations are application name, that service name, namespace, and the region where actually it is deployed, and the cluster name. So I have specified the two destinations: CNN website default orange cluster, and another CNN website default blue cluster. If you remember, this is the service what we have deployed here in the default namespace, CNN website and the default. So the same information are specified in the GTP, and I will be using the traffic policy as the round robin. There are other options of the traffic policy like static proximity and other low round trip time, but round robin would be the one which would be instrumental in showcasing how the packets are actually getting load balance alternatively to each side. The same kind of a GTP is also present on the blue side. So let me now deploy this GTP, and we'll then see the configuration on the Netscaler device. So before deploying the GTP, we can just have a look at the Netscaler appliance. So this is the Netscaler appliance. Here I'm actually having this 177 IP address, what we have seen earlier. And this is the running configuration. You can see that, okay, I have added the GSLB site, orange cluster, blue cluster with this information. And I don't have any GSLB vServer as of now. This should be created using our GTP. The same thing is also present on our blue cluster. So here comes the GTP. Same thing I would be actually deploying on the blue site also. Okay. So, and yeah, that's it. So now let us again have a look at the GSLB vServer. You can see now this GSLB vServer is created. It is actually having this, it is about this CNN app, netscaler.com. Looking at this information, you can see here that there are two service groups associated with this. One is this orange cluster, another is the blue cluster. And the orange cluster is actually having this IP address 175.145, which, if you remember, was the IP address associated with the ingress resource. Same configuration would also be present on our another subordinate site, blue site. So in GSLB, we have a master site and we have a subordinate site. So orange is our master site and blue is our subordinate sites. So you can see the configuration is also created here. Okay, so time for the testing now. As I mentioned earlier, we'll be like sending curl command. So let me just grab this curl command. Before that one, let me just show the name server wise. On this is another machine from the client device. I have introduced like this two name servers. This 175.177 and 175.178. These are nothing but our GSLB ADNS IP addresses. So essentially, our Netscaler GSLB appliance is going to act as a DNS. So you would be sending the request. So now I am sending request this using the curl command. So what happens in the background is this particular request would be sent. First, the DNS query would be sent to this name server, either to orange cluster or the blue site VPX, and it would be responding with one of the IP address. Let us see which IP address it is being used. So you can see that, okay, we are getting a 200 OK response, and the first request is getting resolved to 175.145. This is the orange IP. Let me send the request again. This time the request is getting resolved to the 175.146. If you remember, we had configured the round robin fashion, and we will be like keep on getting the alternate IP addresses. So, this is how actually GSLB thing is working. Now let me make one of the service down. So I will bring the application on the blue side down, and we should see that, okay, the request would be served only from the blue side now. So I'm deleting the service on the blue side. Now we would be actually having service running only on the orange side. And the same configuration will be actually reflected in our is GSLB server. Let us see. You can see the blue side, it has actually showing the state as the down, whereas the other one, it would still be up. Let us send the traffic again. Now you can see the request is coming, always getting resolved from the 145. We are not getting the response from the 146 because that particular site is down. I can do another thing now. Just I'll bring the application up again. And we can actually wait for like around 7 to 10 seconds so that our GSLB device can intelligently detect that service is up and running, and the traffic should again be sent in a round robin fashion. So you can see that, okay, the state has become up now again. And if I send the request one more time, I should be seeing both the IP. You can see that 145 actually came up. 145, 146. And that's the functionality of like our GSLB controller, a very basic use case. And that showcases our capability to configure the Netscaler appliance to take intelligent load balancing decisions for applications which are deployed in multiple distributed clusters. Thank you for the opportunity. We can take questions now.
Okay. Taraj, thank you so much for that. And Mayer, thank you for keeping everybody up on what's going on. We have the first question. Actually, both questions right now are from Donnie Lang. The first one is, can the code in the kubectl command examples shown during the demo be shared out?
Sure. In fact, let me just share a link. We have created one instruct lab. So it's a playground, online playground. We have created a playground for this GSLB controller. So these commands, and it would be actually, you will be like getting that environment with the Kubernetes sites, VPX, everything is actually created. It has a very nice step-by-step documentation and the commands to try these things. So I hope that would be useful, and it also answers the query here.
So the for those of you who may not be familiar, that actually does take you to the hands-on lab, and in the hands-on lab, it will have the documentation and the code, so you can copy that out and use it for whatever functionality that you want there. I also included that link in the webinar chat, so if you would like to, you can go there and collect that up and go ahead and save it. And then the other question was, is dynamic proximity supported or on the roadmap for this?
Static proximity is supported.
It is supported, correct? Okay. All right. Donnie did ask another question. Is a configuration like this, ingress, GSLB, et cetera, supported best through open source channels like GitHub or via Citrix support?
So yeah, we do have GitHub pages also created for the our cloud native portfolio. We have like hem charts and all. They are actually present on the GitHub. So you can actually also raise the issues. It is apart along with the Netscaler documentation. You can also find this information on GitHub pages.
Okay. And do we have any support for dynamic public IPs?
I need to get back this one with some experts on the GSLB side also.
I'm not personally, I don't think the dynamic public IPs are supported, but we can find out what we're going on there. All right. And Donnie, thank you he posted out. He said, incredibly impressed with the Terraform provider, the Ansible, and the Kubernetes offerings. Thank you very much. We appreciate that, Donnie. We're working very hard to make our products just as easy to use as possible. All right, so let's go ahead and wrap up. We appreciate everybody coming today. We would like you to, if you're not already a member, join the community.netscaler.com. It helps you get familiar with the Netscaler. All of our experts, including Daraj and Mayer, are both members there, and they can talk to all of you and answer questions for you in the discussions. You can also get discussions with other members and so forth, other experts like CTPs and so forth. And then you can showcase your expertise and answering questions for people while you're there. And also, please sign up and register for our upcoming events. Thank you, everybody, for coming today, and I hope you have a great day.